So we studied kinetic energy, now we're going to study potential energy. So let's review one more time how all energy is divided. So all energy can be divided into two parts, potential and kinetic. So now we're going to go into more detail about those different potential energies. So we have gravitational, we have elastic, and we have chemical. So what exactly is potential energy then? Potential energy is going to be energy that's stored and waiting to be used later on. So specifically, gravitational potential energy is going to be potential energy due to an object's position. So you can see here in the picture, there's an object that is hoisted up, and it could have the potential to be dropped. Here, this cliff is hanging over, and it could have the potential to break off. This dog is walking on a rope. He has the potential to fall. So for these problems that you're going to do, you need to make sure you recall the value for the acceleration of gravity on Earth. And that, remember, that's 9.8 meters per second squared, and that is on your pink sheet for your quizzes. Okay, so we need to know the units for all these values. So our equation for gravitational potential energy is mass times the acceleration of gravity times height. So for short, that's GPE is m times g times h. And remember, m has to be measured in kilograms. G is going to be measured in meters per second squared because that's an acceleration. And height has to be measured in meters. So we're going to talk about how mass can affect gravitational potential energy. And that's going to be similar to how we talked about how it could be affected kinetic energy. So we're going to use the same analogy here. So we have a truck. We can say that it's 1,000 kilograms, and we add a load to the truck, so we make it heavier. Say we add 500 kilograms. So the total mass now is 1,500. So since we're going to be multiplying by a larger number, we're going to be multiplying by a larger mass, our GPE is going to be larger too. So, how does height affect gravitational potential energy? So, we have our equation there again. GPE is mass times acceleration of gravity times height. So, say we have a cat stuck in a tree. And when you go to help her out, instead of coming to you, she climbs up higher. Well, the same thing applies. You're going to be multiplying by a bigger number, so they're going to also increase the GPE. So let's talk about elastic potential energy. Elastic potential energy is going to be energy due to compression or expansion of an elastic object. So we have a couple different examples here. You have a bouncy ball. This is a bouncy ball in slow motion, notice. It's going to compress, which gives it that bouncy effect. You have the same thing over here on the paddle. A rubber band, if you're going to shoot a rubber band across the room, or a slingshot, something like that. Chemical potential energy. Like coal, charcoal. Potential energy is stored within the chemical bonds of an object. So we're going to burn coal for fuel, right? Another example is batteries. So the common example, you put batteries in a flashlight, you turn it on, and it starts producing light. Another huge example here is food. Okay, so I'm going to show you some rearranged equations. I'm not going to give you an example this time because I think you're all pretty good at the problems. So you have the kinetic energy. Kinetic energy equals 1/2 times mass times velocity squared. Okay, if we rearrange that to solve for mass, mass is going to be kinetic energy over 1/2 times velocity squared. Velocity is going to equal the square root of kinetic energy divided by 1/2 mass. Now we have our GPE equals mass times acceleration of gravity times height. Mass, look, we have two different equations for mass. So you have to look and see what else they give you. Are they going to give you kinetic energy, or are they going to give you potential energy. So mass equals GPE over gravitational acceleration times height. And then finally, if they're asking for height, it's GPE over mg. Okay?